Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through the sine and cosine rules. So you use these to find unknown angles and sides in non-right angled triangles. So non-right angled triangles, we don't use SOHCAHTOA. So here is a non-right angled triangle. We call the sides A, B, and C. It doesn't matter which side you call A, which side you call B, which side you call C. What matters is that you label angle A opposite side A and similarly angle B opposite or facing side B. So by convention, we use uppercase letters for angles and lowercase letters for sides. So in these formula here, if you say an uppercase letter, it means an angle, lowercase letter means a side. So in red here, it tells you when to use these rules. For example, let's say you want to find an angle. If you're given 3 sides, you have to use the cosine rule. If you're given 2 sides in the opposite angle, you use the sine rule. So we use these rules at different times. So that's why we need to learn both. So let's look at an example. So in this triangle here, I'm going to find x, which is a side. So what information am I given? Well, I'm given 2 sides and the angle between. So if I go to my table up here, you'll see that if you want to find a side and you're given 2 sides and angle between, you use the cosine rule, which is this thing here. So again, it doesn't matter which you call side A, B, or C. I'm trying to find C. C is the subject of this equation, so that will be my x here. So what I have here is like C squared equals a squared plus b squared minus 2 times a times b, and then cos of the angle between, cos of c. So because x was like my c, this will be angle c. So to find out what x is, all we do is square root the number we get here. Putting that on your calculator should get about 11.67, and we are done. Let's look at this next triangle. So we want to find a side, and we're given 2 angles and a side. So from the table up here, we see we need to use the sine rule. So the sine rule says A over sine A equals B over sine B. So I want to get x by itself, find out what it equals. Now note, sine 60 is just a number. We actually know it's root 3 over 2. So I can undo dividing by sine 60 by timesing each side by sine 60. So if you put this 10 times sine 60 over sine 65 straight on your calculator, making sure you're in degrees mode, you should get 9.56. So just one way you can see if you're on the right track. Remember that larger angles are always opposite longer sides. So because 10 was opposite 65 degrees and the x was opposite 60, it's opposite a smaller angle, so the answer should be less than 10. So we know we're on the right track. All right, let's look at this one here. So now we're finding an angle. We're finding theta. We're given 3 sides, so we use this formula here, the cosine rule for finding an angle. So it tells us that C will be our theta, which means this side here, 15, will be our little c, side C. So C will equal the cos inverse. Now, it doesn't matter which you call A and B. What matters is that the one we're subtracting, side C, is opposite the angle that we're trying to find. And then on the bottom goes 2 by A by B. So we can put this straight on our calculator, making sure we're in degrees mode. We get about 108 degrees. Now that answer makes sense. 15 was the longest side in this triangle, so that means that this must be the largest angle. Alright, let's now take a look at finding an angle using the sine rule. So when you're using the sine rule to find an angle, sometimes there is an ambiguous case, meaning that there are 2 possible solutions for the angle you're trying to find. So here we have 2 sets of dimensions for a triangle. So let's draw the first one. So it turns out it is possible to draw 2 non-congruent triangles with these dimensions. So I have here B equals 14. And we have A equals 10 and angle A equals 40 degrees. So the two possibilities for such a triangle, it could be obtuse, meaning angle B is obtuse, or it could be an acute triangle. And here, angle B would be acute. You can see in one triangle, the angle opposite the 14 side is obtuse, and in one it's acute. So clearly there are two possibilities for the size of B. It turns out we won't run into the problem with this triangle here. See, I can draw B being 8 this time, but because A is longer, it restricts how we draw the triangle. See, in this triangle, the 40-degree angle is opposite the 10-degree side. So this angle must be less than 40 degrees because it's opposite a shorter side. There is no possibility with these dimensions that this angle could be obtuse. It has to be less than 40. So the first one yields an ambiguous case, the second one doesn't. How can we easily tell when there will be an ambiguous case? So the reason that the first triangle yields an ambiguous case is the angle given 40 degrees was opposite the shorter side. There's no ambiguous case when the given angle is opposite the longer side. So we will get two solutions for B here, but only one solution here. So let's actually go ahead and use the sine rule. So for finding an angle, it tells us that sine B over B is equal to sine A over A. So let's rearrange this equation to get B by itself. The first thing we would do, we undo dividing by 14 by timesing 14. So we'll put a 14 times there. Now to undo sine, we take the sine inverse. We've said before, whenever you're finding an angle, you'll end up using sine, cos, or tan inverse. So it'll just be sine inverse of 14 sine 40 over 10. Now, if we put this in our calculator, making sure we're in degrees mode, we get 64 degrees. So 64 would actually be this here. If you drew a triangle like this would be 64 degrees. But how do we find the other possible solution when there's an ambiguous case? Well, it's actually really easy. If theta is a solution, so too is 180 minus theta. All we have to do is take our first solution and subtract from 180. So 116 degrees is the other possibility. If the triangle was drawn like this would be 116 degrees, and if drawn like this, the acute triangle, it would be 64 degrees. Both of these are valid solutions, and therefore you must give both. So let's look at what would happen when there is no ambiguous case. We'll use the sine rule for an angle again. So sine rule tells us sine B over B, so we're finding this angle here, equals sine A over A. And we're just going to use the same process we used last time. We'll end up getting B equals sine inverse of 8 sine 40 over 10. So putting that in our calculator, we get 31 degrees. Now, if we tried to find the other solution, 180 minus 31 is 149 degrees. But that doesn't work because this angle's 40. If this was 149, the angles in the triangle would add to more than 180, which can never happen. So with the ambiguous case, when you're using the sine rule to find an angle, you can always find the second solution and see whether or not it makes the angle sum more than 180 degrees. All right, let's now look at a harder question involving the cosine rule. So the sine and cosine rules can be used to prove things. In this case, we'll use it to prove you can't have a triangle with sides 2, 4, and 8 centimeters. You can probably tell why that is because 2 plus 4 is less than 8, but we can definitively prove using the cosine rule. So let's try and find the largest angle of this triangle. So that would mean the angle opposite this side here. So using the cosine rule, C would be the cos inverse of, so A and B would be 2 and 4. And then when using the cosine rule to find an angle, the one we subtract is always opposite the one we want to find. And then on the bottom be 2 by A by B. Now the problem is if you just look at this fraction here, we get 2 squared is 416, and then you get minus 64. So it would be minus 48 over 16. So the largest angle would be the cos inverse of 3, which you actually can't do. You can't take the cos inverse or even the sine inverse of an angle more than 1, because if we go back to SOHCAHTOA, cos is adjacent over hypotenuse. The adjacent has to be less than the hypotenuse. So that's why it's impossible here. The largest angle of this triangle would be cos inverse of 3, which doesn't exist. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.